Good morning, everybody. Rhonda Fitz with the NASA IV program here from West Virginia. That's a picture of our facility there, the two buildings, the pink lower one, and then the towers off the north tower on the right-hand side. It's good to be here. Thank you. There's a handful of people here too from IV as well, so hope you guys are familiar with the IV program. If not, please do come and by and talk to us. I won't go into a whole lot of background about our program, but if you aren't familiar with NASA IV, please do come and talk to one of us. So I'm going to jump right in to fault management, which is my passion. It's part of flight software, and it's to me I think it's the most important part, of course. The advantage working at IV program is that we see a lot of different missions. We get to see across the agency a lot of the different projects that are going on. A lot of variety. Class A software, highly critical, safety critical, mission critical. Looking specifically at fault management architectures, we look at the different mission types. And we discovered there's a huge variety in approaches, in the designs, even in terminology, even across the same mission domains. These are truths here. As the complexity of a mission increases, so does the fault management complexity. Some of these statements are pretty obvious. There's a lot of distribution that's being done with the fault management in the software. Highly complex missions obviously need to distribute a lot of that software that takes care of fault management. Documentation as well. You don't oftentimes pick up a fault management document. It's usually embedded within all the other software documentation throughout the system. So gaining that understanding of how, in fact, the flight software is tackling fault management is a big endeavor. You really need a great system understanding of the project. We're looking at capability assessment. When IV assesses a project or a program, we do it from a capability-based analysis perspective. Used to be a lot of artifacts-based analysis, but now we're leaning a lot more towards adaptive IV and looking more to the mission capabilities themselves. We want to improve software assurance, not just IV, but software assurance across the board, safety and mission assurance. That's the goal. And our research here, we're into the third year, funded by the Office of Safety and Mission Assurance out of headquarters. They have a software assurance research program called SARP, and this initiative has been funded called Fault Management Architectures. I'll have a little bit of redundancy in my talk today because I go through the fiscal year 15, 16, and then the current work that I'm doing. Try to just kind of get you guys up to speed on what's been going on. So here are 4 main challenges that from my perspective anyway, when we're talking fault management. We've got increasing complexity. Hardware fault protection, we're talking a lot more of the program, of the mission is being done with flight software. There's so much more importance being placed on software. We're looking at not just collecting ourselves after something goes wrong, but trying to prevent, trying to anticipate, and then maintaining capability rather than just reacting. We've got these fault management systems are embedded within the software, throughout the software in most cases. And so when you validate your flight software, you have to look at those higher level system capability requirements. It may not be obvious with a more direct approach. You've got to basically keep that entire system functionality in mind. We'll talk a little bit about off-nominal conditions, how challenging they are to identify, how we can get our hands wrapped around these ideas of what might possibly happen in our mission. Of course, obviously, we're going to follow the risk. We need to mitigate that risk. We need to anticipate. We need to prevent things going wrong with our mission in order to provide assurance. And of course, we're always trying to improve our assurance, our level of assurance. We need to make sure we're providing the rigor that's needed for our software systems. So this is an overview of our initiative. We had goals to look basically at architectures that were set up for fault management, investigate what kinds of methods or assurance strategies are used here at the program, and a lot of that is tied into the visibility. So these were the three main thrusts that we started off in FY15. These are the lists of the different missions that we had purview to. Now, it wasn't just me. I have to give a shout out to Jarek Whitman, to Ryan Stickway, and to an entire fault management community of interest at the NASA IVMV program that has really been involved in each of these missions in depth. A lot of what goes on with fault management is understanding the system itself, understanding what the flight software does, how it's architected. We started off with a survey of different questions. So a lot of what we did establishing a technical reference was in the journey. The benefit was in the journey because there were a lot of questions that had to be figured out with the system itself. And you see the different mission types there. Launch vehicles, we just tackled this past fiscal year. But you would think that there would be a lot of similarity across the mission domains, but instead we didn't see that very much. You have a different project, you have a different fault management system. So the early goals, we were looking into what kinds of architectures, obviously, but how do you provide assurance? You strategize, you come up with a design on what you want to say. How do you want to say it at a KDP, at a milestone review? What is it that you want to assure that works? And then you work backwards from there. You want to say, how do we come up with the evidence to provide that assurance? Visibility is a very interesting topic because a lot of times we're working remotely, we're independent, we're not working right next to the developers. So we rely on artifacts, we rely on different documents, different software pieces and parts that the developers will give us. We don't always have access to their simulators or to all their code. So it's been a challenge to try and figure out, okay, with what do we start with? If we have a fault tree, if we have a FMEA, if we have just a design documentation, what do we do with that? How do we provide assurance that will ensure that mission will succeed? And of course, as part of any research is the dissemination of those results. So beyond this attack, basically with this study, is being able to share the knowledge that we've garnered with all of our in-depth study. To setting up this technical reference suite, it's a common term, I believe, across NASA that you want to have something to go back on, to look at what your results were and to make some conclusions on your own when you, for like a heritage analysis. So bringing together all this information, we were able to establish this technical reference suite, which was part architecture focused with a lot of details on whether it's distributed or a centralized architecture, how the different layers work, how the different tiers. Then specific assurance strategies that we were able to provide and tying them into our technical framework. What part of the life cycle are we going to say what? What kind of assurance can we provide if we're in the requirements phase or if we're actually all the way back in testing? And what can we do if we have difficulty with the visibility, that a program or a project is not giving us a lot of insight into their program? What can we do? What are some of the IVMV methods or techniques can we basically uncover more of the details that we need? And there's a bullet there on an adverse condition database. I'll talk a little bit more about adverse conditions and establishing this repository of, hey, these are some off-nominal situations that some projects have come across. These are common for certain domains maybe or certain types of missions. And it's almost like a SME in a database. we need an expert to be able to give us some insight so that when we have newer, younger analysts coming in, they've got some place to start. We're not just going to rely on what the project tells us, what are the adverse conditions that they expect to face. We want to add value by coming up with our own and being able to say, hey, wait, did you think of this? We've seen this in another mission that's similar, or we've seen this on a certain component that you're using and another project. So we're bringing together more of that information. And again, this was the second year of the initiative. We worked on bringing together that tech reference suite and giving it a better user interface. We have it populated on Confluence so that it has easier accessibility. Organized the assurance strategy grouping. We're trying to keep that as a dynamic collection of assurance statements because we are, like I said, we're very adaptive with our IVMV. So as projects and things change, those assurance statements are maturing as well. So in this research, there's 3 thrusts. These technical reference products basically are improving on those, getting them out to the point where our analysts can use it and the SNMA, other agents can utilize this information. So here's just a screenshot of a technical reference title page where we have the, I think there's a pointer in here. The architecture matrix would be on the top, then the assurance strategy reference, and then lastly the visibility matrix. And each of these are linked here all in one place where it's easy for anyone to assess. And for example, you jump into an architecture matrix and you go into lots and lots of detail. So there's everything and anything you could want to know about these specific missions as we gain from our community of interest. So basically that's what we accomplished is improving, expanding on those for ease of sharing the information. Second part was the adverse condition database. We started as a prototype. As a matter of fact, I worked with a couple of summer interns to put this together initially, and then we've expanded. We're populating it with the different projects, and everyone comes at it from a different perspective. Again, we don't have a common workflow established yet, which is part of my initiative for this year. Is every project you start off with what the project will give you, but you want to go beyond that. So we want to develop more easier access and more efficient use of this database and give it a user guide basically so everyone can come in and we're all focused on the same terminology. So I gave a quick definition of what we're calling adverse conditions. Subset of off-nominal. Basically, you're preventing a return to nominal operations unless you do something, right? So it all ties into fault management architecture because how you have your flight software architected will determine how you'll be able to react to these adverse conditions. So down here, it's a cool picture. We've had lots of academic discussion on how do you categorize your adverse conditions. Are they the same or are they different from hazardous or anomalous? And so these conditions are all flowed up. You've got basically a condition that you're facing within a certain behavior within a scenario of a specific mission. So you can see how it all depends on this tree here. In order to make sure we were not just throwing together a bunch of adverse conditions and saying, oh, we're great, we've put up this list, right? We took from some Agile Scrum methodologies and threw together a user story workshop. And we got stakeholders together in a room, talked about, hey, why do we care about adverse conditions? What do we want to do with them? What do we consider adverse conditions and how is it important to us and to the work we're doing here? So we went through this process. Now, I'm talking a little bit about Q3 for those of you not familiar. Q1 basically is the nominal case, is the software doing what it's supposed to do. Q2 is the software not doing what it's not supposed to do, those unexpected things. And then Q3 is how is the software reacting in an adverse condition. So the Q3 is really where a lot of our emphasis is being placed for the adverse condition database and for this fault management. So to architect this database, it's not just a flat list. We have lots of, sorry if you can't read that very well, but I can give you a copy if you need one. You've got interrelationships between faults, between failures, hazards, anomalies even. You've got a lot of data tied in with your mission, with your component, and all of that is structured with a database with different relationships, many to many cases. So this was put together over the course of a year and based on a lot of the user story workshop that we went through. Here's a screenshot of a couple screenshots I'll show you here. This is the opening, kind of a generic listing. You've got projects, you've got AC identifiers, names, domains, hazard types, different types of, and we're incorporating all this within our enterprise architecture at the IV&V program with the help of our software assurance team. They're in the process of doing that now. A couple more screenshots, how we talk about these adverse conditions are related to a specific mission. And within this database, it's all in one place. We have the mission, a couple of mission details in there, and then generic domain lists, hazard lists, fault lists. And we can tie in with other databases so we don't have to duplicate the efforts, because there are a lot of different hazard databases that are already out there. So we've got the hooks in place for that. And like I said earlier, we're geared more toward capability-based assessment. So we want to make sure that we've got those capabilities of the mission defined so that if you have a similar capability on your project, then you want to go and follow that capability. Make sure you're addressing it. So this database has been refined and productized so that we have that insight into the off-nominal mission capabilities. And the third part would be then to pass around the information to kind of disseminate it. And that's part of what I'm doing here today as well. I've been to the Space Symposium, the 31st and the 32nd Space Symposium, gave presentations, and there's detailed papers also out on the NEN, if you're familiar with that, or if you need access, you can just contact me as well. So we hope to share that with other folks within the fault management community and with the software assurance community itself. So this is kind of a, like I said, overview. This gives it a chart to, NASA's always looking to, okay, where's the value? What's the value that's come of this? And we want to make sure that that's clear, that we're promoting that knowledge in order to improve the assurance. We want more rigorous IV&V analysis. And that in the same sense, when you understand that, then again, from the developer standpoint, you can anticipate, hey, what do I want to do properly? How can I set this up so that when I want to analyze the architecture later, I'm not running into any troubles? So we're really focusing on that fault management, project areas of vulnerability, high risk, so that we can have that reliable and resilient software. So basically, we're noticing, back, I think it was 4 years ago, Flight Software, kind of picking up from some work that Lorraine Fesk did with the fault management community of practice, identifying a gap here, a need basically amongst the community that fault management really needs the attention that it wasn't getting. It wasn't being addressed early enough in the life cycle. It wasn't given the emphasis that we as a flight software community believe it really does need. We can't afford to put it off and say, well, we'll tackle the nominal, we'll get to the off-nominal later. Time, budget, right? Well, that's not really acceptable. We really need to address it. And there's no reason why you can't address it at the same time you're talking nominal. It takes, as much effort basically to say, okay, here's how I'm going to put the software into place. Here's where the off-nominal, this is what can go wrong. Let's address it then. So hopefully with this adverse condition database, it will help in that regard to keep you thinking. It's really cool because you're always trying to think evil. You're trying to break it. How much fun is that, right? So you really want to focus, get that focus on the fault management within your software development projects, and you'll basically bring down that risk. You know, focus on how you're going to mitigate before things go wrong. Have your architecture assessed to make sure that everything is in place so that when trouble arises, you are in a spot where your software can deal with it. We're talking security, information assurance now. You've got vulnerabilities. It's not just accidental anymore. Sometimes it's malicious. So you really need to be able to be thinking about along those terms. Right now we've got our adverse condition database basically has current projects and current adverse conditions that we're trying to expand on. We're gonna set up a pseudo project of security, and we're gonna come through with all the CWEs that are recently released, and they're updated, and incorporate those into a project as well, so that we have this place where we can double check and make sure we're covering the assurance that we need. So like I said, the additional information, some papers that I've written on the NEN, anything about the Software Assurance Research Program is up there as well, and there's my contact information. I welcome any questions or any comments or any collaborations as well. So, how'd I do on time, Alan?
You did great.
Okay, good.
Questions? Okay, thank you very much.
Sure.